Hello everyone, welcome to Introduction to Structural Design Optimization lecture. We will start with basic information about Visual Programming and Dynamo. Then we will create some structures by using Dynamo truss structures. Then we will optimize them by using Dynamo and robot structural analysis. So, to start, we need to create some truss structures, but how are we going to create it by using Visual Programming? In Visual Programming, instead of text, we are using some nodes, as you can see here, and we are defining the logic by using these nodes. So, to create a truss, we basically first need to define the outlines. Then we can assign them as a truss. So, in a truss, what do we need for defining outlines? We need first lines, right? Here, with this node, we can create lines, but there are two input and one output. Inputs are start point, end point, and output is line. So basically, Dynamo works as reverse engineering. So I need a line. To create a line, I need a start point and end point. That means I need a point, right? Okay, this will be my start point, and this will be my end point. Right now, to create points, I need coordinates. How I'm gonna define coordinates? I can either define it by double clicking on the mouse and writing some number inside it, or as you can see here, my line is already generated, or I can use number or integer slider to define my coordinates. You see, so I get my lines by using these nodes, and I can see the changes immediately on the screen. But I will suggest you guys to use Dynamo in automatic mode. I would like you guys to use it in manual mode, because when your structure or your script gets more complex, then it can cause problems. But for starting, it's okay to use it in automatic. After learning these ones, there are also other important nodes that I want you guys to know. Now I have a point and I want to create multiple points, right? So if I give my x coordinates as a list, I will have multiple lines on the x-axis. What if I want to connect these nodes and create a line, which is a polyline? I can use polyline by points. While searching something on Dynamo, I will suggest you guys to use words after the dot. So if I want to search for this one, I should write by coordinates. It is easier to find it like that. So here, I can connect these nodes by using polycurve by points. As you can see, there is point inputs, and if I connect the points, then I will have a polycurve, as you can see here. Also, you can see the outputs when you click this button here. You can see the outputs of the nodes. Okay, I connect the points together. What if I want to get these lines separately instead of one line? Because here, as you can see, it gives me one line. I can use polycurve nodes. So if I connect this to here, then it will give me each separate line one by one. Now I have 4 lines that is created by 5 points. And what if I want to copy this line on the z-axis? As you remember, I have points here, right? So if I give 2 z coordinates, right now it is default and it is 0. If you don't connect something to node, there are some default values on the nodes. Here also, the connect last to first is false as a default, but you can make it true if you want to change it. Nevertheless, if I give 2 different z values to my z coordinates, one is 0, I would like to put another line to at level 1. If I give 2 and use level as level 1, it will take each individual, create another point on these numbers. Now I have two line groups on my z-axis. As you can see here, as I also see another lines as a group now. What if I want to connect these two nodes together with diagonals? As you can see here, I have the points. Now, instead of connecting points horizontally, which we can also do, we can connect them vertically. Okay, how? I'm going to get these points from this list. I can simply use get item with index. So if I connect the list to here and give the index as 0 because I want to get the first list, as you can see at the end, I will obtain first list. Similarly, I can get another list from here, copy and paste it. First list, I get it. Now I can connect this one together with basically lines. Start point, end point. As you can see, I connect them, but I didn't want to connect them vertically. I want to connect them diagonally. So how I'm gonna do it is I need to delete this point from my list, which is the first one. And if I delete this one and if I connect them, then it will connect these nodes to here. Let's try. I can simply use remove item at index. So here, this is my list and my index of the object that I want to remove, which is 0. Then I'm getting another list. So if I connect that one instead of that one, now I get my diagonals. And the good thing about using Dynamo is it's parametric. So for example, if I change any coordinates from here, for example, 10 and 15, my model will change, but it will keep the structure the same. Okay. We understand what this remove item at index does too. Now let's create a proper structure model. Okay. Let's say I want to create this truss by using nodes that we just learned. Okay. And I want it to be fully parametric. For example, the number of vertical struts will be parametric, the length of the truss, height of the truss, width of the truss, everything will be parametric. Let's create this structure today. Before starting, I need to show this to you. Every node in Dynamo can be also turned into code, as you can see. Sometimes, using this one instead of the node version, better to save some space and control the environment better. So I am going to use this one, but it works the same with this logic. So here's XYZ coordinates. Okay. My point one is, let's say 0, 0, 0. My point two is again same, and I need a point 3 because there was a 3. It was 3D structure, and I need 3 different nodes in the coordinate system. Now the thing is, I want to adjust x, y, z values dynamically. So I don't want to give the hard-coded value. I want to change them by integer slider. How I'm gonna do it is I'm going to change them with letters instead of hard-coded numbers. And as you can see, it becomes input. Now I can use number slider or integer slider to control these values. As you can see, I can control the place of this node. So all of my three nodes become in the same one because there are z and y values. Also, I need to adjust. Okay, this first node will be here because it is 0, 0, 0. Because it is on the x-axis. Now let's change the y value of other 2 points. I will use again number selector to control them. So here my first point is on the y direction, negative y direction, and the other one will be the negative y direction. So I got 3 points. Now I just need to lift these 3 points to some height because as you remember the truss 1, 2, 3, I have 3 points and 2 of them are the same level, same height. So how I'm going to do it is I'm going to change the z value. Let's say, let's put this letter instead of z value. And I'm going to control it with, again, integer slider. Now, as you can see, we got the triangle. Now we have x values here. And as you can see, I can move the points in the direction, in the x direction. But the thing is, I want to have multiple of these points so that I can create the outlines of my truss. So either I can give a list instead of number slider, the points that I want to create my truss with. As you can see, but then it's not easy to change it. This is this if I want to change the length of my truss, if I want to change the number of vertical truss. Instead of this one, I can use a list sequence. So my truss start from 0, my x values start from 0, and let's say go to 10 with the 5 steps. If you look at the outputs, there are 5 inputs and it goes to 10 with 5 steps. As you can see, there are 5 elements in the list. So here, if I change, for example, the step size, if I want to vertical stress more, I can say, okay, go to with 10 step. Then I will have my elements like this. If I say, okay, go to 10 in 2 steps, there will be only 2 elements. And also I can change the x values. For example, let's go to 15 with 5 steps. You see? Now the truss becomes parametric, but still changing the numbers one by one. So instead of that, similarly to here, we can put some representation instead of numbers. So here you can say, okay, from 0 to length of my truss, go to the panel number. Now I need to define the length of the truss, the panel number. So if I increase the length of the truss, it will move along the x-axis. And if I increase the panel number, the vertical stress number will increase. You see? Now we have parametric model. Okay, after this point, it is easy to move forward. What do we need to do is just, connect these points together. As you can see here, just make the connections. And we already know that how to do it, right? So let's create a list, right, from these points. So what I have here is I have the points one by one, you see. and I will connect them with a polycurve by points. Since I have points here, I will get my beams. Simple, right? Okay, but there are just one line, and I don't want that. I want separate planes in my truss. So I need to separate them. You learn how to do it by using polycurve.curves. Now I have lines, and the good thing about it is if I change the vertical struts number and or panel number, I will have the lines in a list. Okay, nice. Since we created these beams right now, let's create the vertical connections. So as you remember the truss, every 3 points needs to be connected with each other, right? So I need to create a list that contains all of these nodes together. But if I get them as a list, they will be like in line. So all the lists will be together. So here, one line, another line, and another line. So I need to combine them in such a way that only the 3 dots in each segment will be together to connect them with polyline. So this combine function will combine the list together. Here I have 3 lists, and it will combine them by taking the first element and creating a list, and taking the second element and creating a list, and so on. So to do that, I will again use this list create, and I will use it as my combine function, and my list will come here. Okay, so at the end I will have the points of each list that contains each 3 points in each section. You see, now I can connect them together. How? By using polyline by curves again. So you will see here that, okay, it connect them together, but it didn't connect the end point to the start point, because as you remember, connecting last to first is false. Now, if I make it true, then it will connect them together. It will also add the last element to the list. You see? Now I have outlines of my truss. The only thing that's left is creating the bracings for each section. Let's see the truss again. You see each section has bracing, and let's create those bracings. Okay, for bracing, first we need to do is we need to connect them diagonally and make the opposite, and it will be bracings. So we have the points here. So how we are going to connect them diagonally? As you remember, I have list of points here and here. And if I do drop the first item and connect them with the line by points, it will create the diagonals. Let's do it. So I need to drop this item here and this item. I will use drop items or remove items. You can use both of them, and my list will come from here. And my amount is 1. It will drop the first one from this. And let's see. You see the blue points here? It shows the nodes that my list contains. So if we connect the first list to here, now it will create the diagonals. But first we also need to delete these one from the list. I will do the same group items, but from another list right now. And this time I will drop the last one. See? Now I got my diagonals. And need to do opposite of them again. How can I do it? Is basically I need to change the numbers, right? If I make this one -1, and if I make this one 1, it will change the direction of them. The node that has been dropped, and it will connect them together. Now here at this point, we need to create them for other sites also. And there's a particular way to do it, which is custom node we will see in upcoming lectures. But for now, we can basically copy them like this, but it will be a little confusing because the script will be a little bit long. So what we can do is we can basically turn them into code. So as you see, we save lots of graphical content. Now what I can do is I can copy and paste this code instead of all the nodes to create other bracing. So I just need to change the input points as you see here. Look, our truss is done. It is fully parametric truss. Basically, we can change every value by just changing these inputs, which is pretty useful for optimization purposes. And then we can say these are the inputs, and we are grouping with Control G. So I can change the length of the truss, the number of vertical truss, width of the truss, or height of the truss. And this is all for this week. I hope you understand everything. If not, you feel free to contact with me. To make the script nicer, you can group them together. Let's say these are the beams. You can change the color of the group. You can, let's say this is the blue one. You can group others. You can write the name of the inputs, for example. This is the length. So now we know what is it. And this is the panel number. Now we learned how to create the truss. Bye-bye.